Hi, I'm Brad Dodrell. I'm a senior scientist with Lakeshore Cryotronics, and today I want to give you a quick look at Lakeshore's new Model 8600 vibrating sample magnetometer. I'm going to give you a brief overview of Lakeshore's new vibrating sample magnetometer, the Series 8600 VSM systems. What you are seeing here is what we call the 8607, which resides on a settable gap 7-inch electromagnet. That is, there are 7-inch, the magnet poles are 7 inches in diameter. They're tapered to a 2-inch pole face. Mounted on the pole faces are the VSM sensing coils as well as a Hall probe for providing closed-loop control of the magnetic field. This is a vibration isolation frame to which the VSM head is connected, and this is the instrumentation console, and I'll talk in more detail about that soon. Firstly, what I want to do though is point out that we have 6 settable gaps here, although for the VSM application we're only using 4 of them. Gaps 1 and 2 are for room temperature operation, and they provide sample access of 3.5 and 8 millimeters respectively. At gap 1, which is our narrowest gap, we can achieve our highest applied magnetic fields of just under 33 kiloersted, and this gap is also where we achieve our best noise performance of 25 nano EMU RMS noise at 10 seconds per point averaging. This is actually a conservative specification because what we typically measure is closer to 10 nano EMU. Currently, this is set to gap 3, which accommodates our single-stage variable temperature option, which I'll talk more about shortly. In a VSM, we do not use either gap 4 or 6. We do, however, use gap 5, which is designed to accommodate a helium-nitrogen cryostat and high-temperature oven option. Changing from one gap to another is very, very simple. You simply unscrew these 4 bolts and pull this fixture towards you, and then switch this to another gap setting. Push this back in place, screw the 4 bolts back in, and you're ready to go. The other thing that's interesting about this is once the VSM is calibrated at each one of these gap configurations, whenever you change to a different gap configuration, you no longer need to recalibrate the VSM. All of that information is saved to a configuration file in the software. On the instrumentation console, we have a variety of different electronics. We have the Model 737 VSM controller. Inside this box is the electronics that drive the VSM head, and there's also a narrow bandwidth lock-in amplifier that is tuned to the drive frequency of the VSM head, which is 82 Hertz. And thirdly, there is a Gauss meter in here, which is connected to the Hall probe that is mounted to the electromagnet pole faces to once again provide closed-loop control of the magnetic field. If you have a variable temperature option, then you also have a Model 336 temperature controller and a gas flow controller. One of the novel things we've done in this system is completely automate gas control and flow control so that one can perform variable temperature measurements in a completely unattended fashion. And lastly, of course, we have data acquisition control and analysis software for collecting the data, analyzing the data, and so on. As positioned now, you can see that the VSM sample rod and therefore the sample that you're measuring is positioned within the magnet and sensing coil gap. To remove a sample, this has been automated in the software, so one simply enables that function, and you can see that the entire head is lifted up to a position that is convenient for exchanging the sample. And then you simply detach your rod. You can see here I just have a piece of magnetic tape on the end of this sample rod. Replace it with a new sample and put the rod back in place, and then simply move it back into the magnet gap. Now for positioning or saddling the sample within the sensing coils, We have three independent controls. We have precision micrometers here and here for adjusting the sample in both the X and the Y direction, respectively. For positioning the sample in the Z direction, this is actually handled through the software, since we have the ability to move the sample. So for example, I will move it here in 10 millimeter steps to give you an indication, okay, that it is definitely moving, all right? Okay, and then the other thing I wanted to show you is the auto rotation, included by default with all 8600 systems. And here we can continuously rotate the sample in any direction. So in this case, I'm simply going to rotate it 360 degrees. And you can see that it is automatically rotating. So of course, this function enables you to measure, for example, rotational hysteresis in materials. If you're measuring thin film and you want to do a hysteresis loop measurement with the film oriented both in plane and out of plane, then all of this can be handled automatically via the software.